A very good day to Dr. Shabuddin, Dr. Istas, Dr. Nick, and Dr. Iskandar. My name is Young Joyi, and today I will do my undergraduate project presentation entitled Development of Photovoltaic Power System for UAV. So UAV is unmanned aerial vehicles, defined as the air vehicles that operate autonomously and controlled telematically without pilot on board. So the problem identification for this project is the challenge to maintain constant power supply to the load due to the inconsistent weather condition, as the power generated is highly dependent on irradiance. Second is the harness of solar energy, where the efficiency of the PV cell drop due to temperature, sun intensity, and the PV cell arrangement. So the objective of this project is to develop methodology for solar powered system design and to perform the setup. The second objective is to perform parametric study and performance data collection and analyze on PV power system. The scope of this project is I create the PV power system for a fixed wing prone flying wing UAV. The UAV weight is less than 1.2 kg. It's a hand-launched, low-altitude solar power UAV, and the photovoltaic device is monocrystalline silicon cell, which arranged in series mounted on the wing. So there are few configurations of UAV, which include the multi-rotor UAV, fixed-wing UAV, single-rotor UAV, and hybrid UAV. So different configuration and use of UAV are used in different applications. Next is the basic electronic component in PV power system. So the first is the brushless motor, which spin the propeller and generate thrust. Second is the electronic controller speed, which control motor speed, direction, and dynamic speed. Third is the battery, which act as the energy storage device in the system. The fourth is the photovoltaic device, which converts solar energy to electrical energy. And last is the solar charge controller. So basically there are two types of solar charge controller, the PWM solar charge controller and maximum power point tracker solar charge controller. So in this project, the MPPT is used to regulate the battery charging process. Next, I will present on the methodology flow. First, I will develop a solar simulator. Second, I obtain the irradiance curve in Skudai area. Third, I perform checking and encapsulation and soldering of PV cell. Fourth, I do experiment to study the IV characteristic of PV cell. And lastly, I develop the integrated PV power system. First is the solar simulator. So the objective is to create a small-scale solar simulator that able to provide a spectral and optical composition similar to the sunlight intensity for execution of experiment. So as you can see, this is the design of the solar simulator that I create. It consists of table, reflector, test area, two full spectrum LED light, and an adjustable rope. And the suggested height that I use is 0.14 meter away from the test area. So in order to ensure that the result is reliable when we perform experiment in the solar simulator, so there are few performance classification according to the ASTM E927 standard. So the first one is spectrum match, where the full spectrum LED light able to give on UV and IR ray. Second is the spatial non-uniformity. There is calculation and I obtain a class C, which is less than 10%. And the third is temporal instability. Also, I obtain a class B. So in short, so the solar simulator that I create, it's within the acceptable limit according to the ASTM. Thus, the result is reliable. Second, I obtain the irradiance curve in Skudai area, which is to ensure that Skudai area can provide the suitable flying condition for the solar powered UAV. So as you can see, here is the on the right side is the mean irradiance data is collected The location is at the aerolab, where the latitude and longitude is as shown there. The surrounding temperature is 31 degrees Celsius at the condition with a clear sky and full sun. The third one, it's the experiment is executed for a whole week, starting from 27 August to 2 September. And the time, it's throughout the day from 7 morning until 6 in the evening. The equipment used is the RS Pro solar meter. So as you can see from the graph, the maximum irradiance that occur is around 1 p.m., which the irradiance obtained is 960 watt per meter square. So third, I do the checking on the incoming PV cell. So when the PV cell is received, I receive the PV cell from overseas. So I do the checking on every cell to ensure that the the performance are uniform and there is no defective cell. So as you can see from the table, the result obtained is quite uniform, where there is no big gap difference. So therefore, I conclude that all PV cell is functioning well. Next, I do the encapsulation, which the purpose is to maintain the performance of cell for a longer time. The material to do the encapsulation, I use a transparent sticker, and in order to ensure that the material, the type, the quality of the transparent sticker, I do a light transmissivity test on the sticker. And as you see from the graph, the light transmissivity is up to 99.41%, which is therefore it does not adjust the performance of the PV cell after I perform the encapsulation. Next is the soldering process. The arrangement of the PV cell is as shown. It's arranged in series. The soldering is performed and connected using dog bone connector. Next, once the soldering process is done, I do the experiment to investigate the relationship between the irradiance, voltage, and current. As you can see, at maximum irradiance of 1000 watt per meter square, the open circuit voltage is up to 6.08 watt and short circuit current of 4.84 ampere. So by having both these parameters, then I can predict the IV curve at different irradiance. So this IV curve is very useful in the analysis afterwards. So next experiment is to carry out detailed study on the IV characteristic of the power of the PV cell. So here on the right side is the circuit of at the setup and the circuit of the experiment. Okay, so here is the result where the IV and PV curve is created. So as you can see, the efficiency is 13.32%, and also the power maximum, if you can see, notice the power at maximum point is 0.473 watt. So therefore, I conclude that the power is too low and would be hard to support the PV powered system. So next is the development of integrated power circuit. So therefore, I do not do the testing in the solar simulator and do it at outdoor with full sun, with hoping for a higher intensity. So the test run, however, the test run is still unsuccessful because the PV cell could not provide sufficient stable power to operate the ESC signal generator and micro brushless motor. So I have connected an external battery supply to the ESC signal generator, and hoping that by increasing the ESC signal, it can start the motor. However, it's still unsuccessful. So therefore, I think I need to improve on the power supply. So here is the improved design of the PV power circuit that I create. So on the left side, it's the selection of component. The improvement that I did is to double the number of the PV cell in order to increase the power supply to the motor. And second, I install a maximum power point tracker to the system to maximize the amount of power obtained from the PV cell. So the efficiency of MPPT is very high. It can be up to 98%. So by refer to the previous analysis that I did, so I predict, here is the IV and PV trend predicted at 5,000 watt per meter squared. So as you can see, with the improved design, the power at maximum point is now 17.94 volt, which is also the power generated from the system. So by putting into the graph of power required and power available at steady cruise, so we can see that the power available is able to support the solar power UAV to fly at a steady cruise with velocity from 4 meter per second to 70 meter per second. Also, the recommended cruising speed is 10 meters per second, as it has the minimum power required of. So back to the irradiance curve that I plot just now. So for a irradiance of 500 meter per second, we can easily obtain from within the time from 9 a.m. to 3:30 p.m. So therefore, the recommending flying time, it's 9 a.m. and 3:30 p.m. So the conclusion of this project, the conclusion is the objective of this project has achieved. I have developed the methodology for the solar power system design and perform the setup, which I do the solar simulator, I get the irradiance, I do checking, soldering and encapsulation of PV cell. Next, also I do perform parametric study and performance data correction and analyze on the PV power system, where I did the IV and PV curve, study on the IV characteristics, and predict the performance of the PV power system. So next is the recommendation for future work. So I would recommend to do investigation on other factors that contribute to decrease of power output, such as pitching and rolling angle and operating temperature of the cell. Second, I would recommend to do the development of PV power system based on the improved design that I proposed just now. So the last part of my presentation is the milestone. So here's the Gantt chart of my UGP2, where I'm now currently in the second last week of my UGP2. So that's all for my presentation. Thank you so much.